welcome to the ASRC, the Aviation Service Research Center of the Hong Kong Polytechnic University based in Hong Kong. I'm Anita. I have been working in ASRC for over 8 years. ASRC predominantly focuses on aviation maintenance, repair, and overhaul, as well as their advanced manufacturing solutions. Today, I'm going to introduce some of our research projects that we're working on in the past years. Now, I'll pass to Artis to introduce those projects.
Thank you, Nita. Let's have a look at one of our current projects. This is Aircraft Digital Twins project. We also call it as EDIT. This project links with the Boeing project that is on aircraft coating and paint analysis. And we have some common elements in these two projects. Actually, currently we are working on EDIT project, and we have some common elements from our previous project that was on damage assessment and damage detection. But this time we are using some new sensors and technologies like terahertz imaging, hyperspectral imaging, and ultrasound imaging. In order to gather some information and data, we make use an airborne camera like hyperspectral camera mounted on a commercial drone like DJI 350M.
Hyperspectral cameras, unlike normal cameras and even our own eyes, do not have 3 wavelength ranges. Rather, they have 128 or more. This means that every point is a spectrum of reflected light and hence an indication of the chemical nature of that point. This should allow us to determine if the coating has issues or not, and if fasteners have been struck by lightning or not, or if the paint has degraded.
To capture the hyperspectral data, first need to set the focus of the camera, and once the focus has been set, the camera can start scanning the area that we are interested in. The camera that mounts on the drone is Vacuum IQ, which is a portable hyperspectral camera. It will take few seconds to a minute to perform the scanning. It is entirely dependent on the light source. After scanning the surface, the user needs to define the white reference area to calibrate the data. Once the calibration has been done, the result will be available on the screen immediately, and the user can view the result right after. After capturing the data, all those results are exported to another analysis software. This software allows different spectral data shown on the same plot for easier comparison. As you can see on the screen now, the orange rectangle illustrates the calibration board. The reflectance is always around 1 at all wavelengths, which shows the light source is giving a full spectrum. Different damaged areas are identified. The plot shows all reflectance of those damaged, as well as the non-damaged area, which are defined by purple and green rectangle.
Now let's have a look at another wavelength range like infrared. The type of system we are now looking at is another form of active thermography known as flash thermography.
Within this system, unlike passive thermography, we stimulate the component to obtain better information about the part. Here we use a powerful flash lamp of 6000 joules to flash an optical pulse onto the surface in the visual range of wavelength. This creates a thermal wave in the component, and we record a video in the infrared of the cooling at the surface. The cooling rate will depend on the subsurface features, and with signal processing, these can be revealed.
The device first triggers a 3D scanner to capture the surface profile and then followed by a flash thermography. To perform flash thermography, a high power lamp is needed as a heat source to induce heat into the part. A thermal camera records the temperature change by capturing 8 to 10 seconds of thermal video. After that, thermal signal reconstruction is used to calculate the subsurface damage. Now you can see the screen with surface profile at the top right of the software and the subsurface damage inspection result at the bottom right. After getting both surface and subsurface profile data, the software will combine two datasets into one volumetric data that is shown on screen now. The operator can easily rotate the 3D model and have a better view and idea of the parts at different angles. So here is the corrosion scanner that used to calculate and detect the material removed for those damaged parts for the aircraft. And for this scanner, we have got a 3D scanner inside which uses a structural light scanner. And to do the calculation, we have used the surface reconstruction to calculate how deep that the material has been removed. So for example, this panel. And here you can also see the structural light, it's flashing. It gives different pattern to do the surface recognition. The user first needs to adjust the exposure, which is totally dependent on the material reflectivity. Then the user may switch the unit between mm and thou with their own preference. The scanner only takes 1 second to capture the 3D point cloud with the structural light. The point cloud will then be divided into different grids. The user is required to select the blend out area manually. Then user need to define the surface form as well to do the surface reconstruction, such as cylinder or plane. The result will be calculated and 4 types of result can be shown by the software: maximum, minimum, average, and center weighted average. The software also allows user to save the data into either image or PDF file, while PDF file is able to save all the result into one single file. After running different types of inspection on aircraft, for example flash thermography, hyperspectral, etc., every results can be stored in the database and mapped onto the aircraft 3D model. When the operator selects different parts on aircraft 3D model, all relevant inspection results and history, including repair record, will be available at the same time. This could help operators have a better idea and full understanding of the aircraft.
Thanks very much for watching. I hope you found it useful and informative. If you would like to find more information regarding ASRC, please visit our website, and also you can follow us on the social media. Hope to hear from you soon. Thanks to join us and have a great day.